Hello everybody, and welcome to the early morning session this morning. And yeah, it was just lovely to have an opportunity to share with you some of the activities and ideas that I've been working with teachers for the last few years in Oz and now over in New Zealand. And it's an opportunity to share these with you. What I tend to do is I'll tend to cram my slides with a few ideas, because I know as teachers we like to go back through these in our own time, and I'd rather give you a lot of different examples of these. So we will go through the slides at quite a rate, but the idea is we've got time then to go back and look at these, and I will allow myself for you to contact me as well. Just a quick background. So yeah, trained in the UK, then I went over to the Kuwait, and I was a primary teacher there for about 11 years, and then moved to Australia in Melbourne. And again, I stayed as a primary maths teacher, and I did some maths work in the schools there. And then we moved to Australia, so again up to Queensland, and that's where we were for like 13 years. And yeah, I was a numeracy coach, and then I was the Queensland State Advisor for Maths in school advisor, and that gave me loads of opportunities every day to go in schools and sit with teachers and basically work with them, give them that confidence again around balancing the curriculum and writing their own resources. And then yeah, moved across to New Zealand in December 2019, just before COVID. And I was invited to join the DIMIC team, which I did for about 3 or 4 months. And then I did the stint as a DP all through 2020. And then this year, I've gone back to working as an advisor with my Aussie schools and my New Zealand schools, and doing a bit of a project with the ministry. So that's just a quick background. And so let's go through. So the backdrop today, it's just, I want you to walk away with a few ideas that you can try, play with, because I think as teachers, we just want time to try and play with some ideas that have worked. And I'll share with you today some of the high impact strategies that were voted for by teachers as making the most difference to kids' disposition and performance in the shortest space of time. So it all comes from like a 5-year project we did across the Queensland schools and started over here. And we've got this background of a curriculum refresh, and as teachers, we can sometimes get a bit confused and overwhelmed, and I'm finding that with the schools I'm working with at the moment. And as teachers, we just want to just show us a nice balanced approach, and then we can pick and choose what works for us on our own learning journeys as teachers, to match our own confidence with maths, and also to match the kids that we have in front of us, because they change every year. And don't forget, maths is just one part of our primary intermediate curriculum. So we have to do all these things. And the idea is, it's trying to get that balance between the two. Both on their own don't necessarily work. No one says it's one versus the other. But sadly, we live in a world where, there's almost money to be made by positioning teachers down one end or the other. As a teacher, that for 10 years hasn't really helped any teachers, because we just show us what we can do and we can make the professional judgments ourselves. Because as teachers, we're professionals. We know what's best for our kids. We go to school every day wanting to do the best for our kids. So let us just pick and choose and not be forced down one side or the other. So the idea today is retention, because retention is a critical part of just building up. And these rapid routines can be 5 minutes, because that's what teachers want. Show me something in 5 minutes that I can extend if I want, or make even shorter than that. So I'll give you a bit of a background of that. The curriculum we use here, is the same across most countries. It's got proficiency strands or practices, and you'll see today when I take you through some of these quick examples that there's 5 main areas of mathematical proficiency. And if a child's got one of these that is slightly weak, that will manifest itself in disengagement. A teacher saying, I've taught them this 5 times, they just don't get it yet. It happens all the time. Some kids just, why are we doing that? That's the orange one missing. Forgetting what to do, that's the purple procedural one missing. Not being able to understand different ways we represent things, that's conceptual understanding missing. Kids saying, why do I have to explain all the time? It's so boring, that's adaptive reasoning missing. So all these things, and some of the work we're doing at the moment is just showing teachers and ākonga where your strengths lie, because all these things come together. And as teachers, we try and bring all these in. They're hidden in the curriculum, and in the New Zealand curriculum, they're there, but they're not always at the forefront. So visualizing these is an area. And just a quick spotlight on what the rapid routines do. We're trying just to bring together the kids and repairing it, because with the concept in there, it just means the procedure is cemented and the kids won't forget. So these rapid routines I'm sharing with you will be ways for you to just check as a teacher. You can use these for formative assessment as well. That's some of my New Zealand teachers are now having a play with. So really, it's just getting kids drawing, using number lines, renaming. It's trying to get kids along those sorts of areas. That's conceptual understanding, and that will flavour the questions I'll be sharing with you in a few minutes. It's also, again, I've just put number line on because that is a fantastic way of representing, whether it's horizontal, whether it's vertical, whether it's contextualized as a thermometer or a radial. Kids use these all the time because it's got some great fractional awareness, some great geometric interpretations, because most of their gaming, they have energy bars, stamina bars, and it's all fractional representation. It's all geometrical interpretation. That's conceptual understanding, recognizing it in different contexts. So you can bring those contexts in for some of these routines that I'll share. And also you can imagine, once they get those different representations, you've got discourse, you've got discussion, you've got challenging, proving, defending, all those sorts of verbs that we as teachers strive to inject. And most kids do, because the same kids in English are happy to justify, prove, defend. And they come to maths often and they just seem to switch off. And I think that's what we find when we talk to our teachers, is the same kid just has different pedagogy expectations in the same classroom. So the kids can do it. It's just changing their worldview of what maths is. And so really, conceptual understanding, getting them to draw, getting them to represent, getting them to connect to a type of context, that's your evidence of conceptual understanding. So they're quite easy to do, because again, as teachers, we don't want to have to go and buy another book that says, no, conceptual understanding now or whatever. It's just show me a quick things that I can do. So that's a bit of your background, and it links to your pedagogies, because in our pedagogies here, our effective pedagogies, opportunities to learn is planning, reactivation. And that's the area that we know teachers can instantly build in, not add on, build in, and have almost instantaneous responses, positive changes in kids' attitude and kids' retention. And for a teacher, if I can reduce the content overload, if I can reduce my reteaching time, that to me is my first step. Okay, that's got me going now, because that's going to save me a lot of time. And we know around everything, activate and retain is important. Those familiar with Peter Sullivan's open-ended books and his work as well, Smith and Stein, Cohn and Lowton, all the mathematical inquiry, you've got to promote that fluency and transfer at the same time, because we know in the news at the moment, there's a lot of push and shove around problem solving versus explicit teaching, and it shouldn't be that. It's a balance. That's what teachers go to at university. We're shown a balance. So let us just play in a balanced arena. And it links into this, because as teachers here, we're doing this range of meaningful contexts, which helps us associate with the leveling that you've got in your country. And the verbs behind this, if you take what thinking mathematically is, it's all these words: exploring, questioning, conjecturing. So they're all there. So we thought, okay, a few years ago, teachers said, Rob, could we just start as teachers making some quick 5-minute things that can, A, sort out fluency, understanding, but at the same time, promote mathematical thinking, almost in a 5 or 10-minute task. And then I can flavor those with different content strands that I, as a teacher, feel we need to go back. And that was the basis of these. So the rationale, we're going to take the fluency, the understanding, and the reasoning, and try and bring these together in little 5-minute, 10-minute activities that you can pepper your week with. The key factor, the key takeaway today would be this. We found, and I won't bore you with all the stats and things, but basically over 5 years, the schools and the teachers who were using rapid routines that were not connected to what they're doing were able to gauge the most relative gain in student retention and disposition. So we're trying to say, sometimes use the same ones as your unit, but you're going to get better bang for buck if you make sure your rapid routines are not connected to what they're doing at the moment. It gives them time to reactivate that. I will share with you at the end a link, because at the moment, these aren't mine. I don't create resources, because in New Zealand, there's enough resources out there for any teacher to get their heads around. It's just bringing them to the forefront. Part of my project I'm doing with the ministry is to show teachers across New Zealand what's already here and how to best utilize what we've got, because we don't want to keep finding things. The ideas and elaborations document, I brought it together because these are what I'm showing teachers to do to make rapid recalls and rapid routines. Because if I can show you to make them, then you don't need them anymore, and you can have that autonomy and the creativity, which I think is what we choose teaching for, to be autonomous, confident, and be flexible, and to be creative, not to be keep being told you must do it this way or you must do it that way. So let's show you how you can start this journey yourself, and you can have that independence to do it. So what these things show, because when you get into these elaborations, it actually gives you so many visual examples. And I'm not saying that I'm preaching to the converted here, but most people who join math sites and maths groups, we find probably know all this already. But we're finding in the sector, when I'm traveling around North Island and South Island, sometimes teachers have said, oh, I remember these, I've forgotten. I said, look, utilize them, bring them back, reinvigorate them, because they're actually going to be really useful to empower you to formatively assess. So when you see things like this, it starts to bring it out. So again, these aren't me making things up. I've just taken the words and put them into a document that's readily accessible. And they're useful in a minute when I show you these. So, what it does, you can then link them through. I'll just show you this one here, because I think when teachers do this, it's showing them, right, let's have a quick little workshop here, 5 minutes. Let's take one of these and let's just see what evidence are we looking for if we want to see that kids have got the full proficiency set. Now, I don't think this was communicated all that well in the curriculum here. It's in the background information, but other countries like Singapore bring this to the front. Scandinavia bring this to the front. Australia 5 years ago brings it to the front. Because as a teacher, it's useful. I can start to see where these things are. And a lot of teachers actually stick with their kids and say, look, if your strength isn't adaptive reasoning, what can we do in the class to promote that? Let's go on a learning journey together. And it helps kids value things. So down the track, there might be another opportunity to talk about these in a little bit more detail. Okay. And again, if you level 4, those elaborations I've just shown you, it brings full examples in that gives teachers right. And some teachers that I'm working with in year 7 and 8 at the moment have actually said to the kids, if we want assessment capable kids, let's show them this up front. Rapid routines we're going to do this term are about this, before kids say, oh, why are we doing these again? They're boring. You say, well, as a teacher, this is what you need to demonstrate. And so let's go on a learning journey this term through a few rapid routines and see if we can, as a whole class, get these ideas, explore them, investigate them, see which ones you like, see which ones you don't like. So let's go into them. So the first sort of one is what we call, remember, these names, I just made them. I don't want you to think you've got to use these names. I love it when teachers and schools just write to me and say, Rob, we've changed the names to whatever to fit our school. Excellent, go for it. So just my names are just there to help me organize my computer files, okay? So discuss and defend. These are generally 2 or 3 procedural type questions to reactivate and retain. We know from the recent media stuff that Audrey Tan's been doing, there's a definite need, because New Zealand students are losing their ability to have the basics, and linking to competencies, and linking to the higher order thinking is meant to promote and enhance basic knowledge, not meant to drop it down. So we need to make sure, as we said, to balance those things. So these are about all strands. It's about teacher facilitating. It's about one question. And it's about getting the kids to activate those thinking. And you can make them by basing yourselves around these. So what we've got teachers to do is to prove to them that you, as teachers, can write as good a resource as anybody else. Over the years, I've done consultancy work for Matafique, Mathletics, all those companies, visiting them, talking to their teams. And quite often they're teachers, just like you and I, they're teachers, but they've been chosen there. And they search and they look for different activities. They give them to a software engineer and it makes it all glitzy and grand, sell them back to schools, 10 times the price. But if you give teachers time and trust, we can make our own. And I'd rather you make your own than have to waste more money on buying and relying on other people's resources. So these sorts of things here are, we've just got teachers in 20 minutes say, take these, choose a question stem, like how would you calculate? And then choose some numbers from the ideas and elaborations. Maybe what number comes next, because that's in there. Just choose some. You can differentiate them. You know, how many balls is a third? Sketch and label one. It's just quick ways. And yes, you've probably already got hundreds of these, which is great. But sometimes it's good just to keep a sequential development of them and give kids time to practice the same concept, but with different numbers, different ideas. It's just that way. But the main thing is it brings our attention to the true intent of the curriculum, because there's a lot of things in there that I have found. And to make you as teachers feel better, at the moment, I'm working with principals, deputies, maths leads, who we are core leads, and the data and the survey we're collecting is sometimes up to 50%. It's even like on my thing, 60% of these experiences aren't fully familiar with these. Because as New Zealand teachers, I think we get lost in the mix of so many documents. When I arrived here 18 months ago, it was like, whoa, how can teachers survive with this document, this tool, this tool, this tool, this tool? And it's like, let's just bring that. It's like I said, my joke is, it's like Lord of the Rings. You want one to bring them all together, because as a teacher, you want to minimize the stress. So this document for rapid routines works well. And again, then you do choose one question, and then you can throw in all that lovely work by Shelley Parrish and Joe Bowler about turning that into a quick 3 or 4 minute number talk, because you're trying to get the defense and those thinking mathematically skills up. And I've just tried another one here with place value in level 3, going through those preemptive skills just to give kids an opportunity. So your school can say, at our school, our rapid routines give kids opportunities to reactivate and retain the basics. That will empower them, make them more confident, make them more able to engage in mixed ability inquiry type problems, and just give them the confidence they need, the confidence that they deserve to have times to go back to these basic skills. We know if you're level 4, algebra at the moment is a nightmare for some teachers, and it's not algebraic thinking that's the problem. The problem is kids don't know how to, or forgotten how to multiply, add and subtract positive and negative integers. They've forgotten how to apply their times tables to find common denominators. They've forgotten how to use distributive law, associative law, which come back down into level 1 and 2. So we need to really get those things going to help the whole school give these kids a real possible advantage to get through. A couple of schools have shared things. One school at the moment is getting their kids to play around with numbers and let them explore as a discuss and defend. Go into them, and these headings are just generic. How there's no in groups of 2 or 3, here's a problem of the day, you've got 2 or 3 minutes. Is there a way to estimate this? Is there a way to compensate? Is there a way to decompose? Are there any others that you could do? And you know, the kids are on the floor, off they go, year 7s and 8s on their boards, talking, discussing. Teachers, there's a few teachers came with me to watch this one. Watch what they can do, recognize their strengths, see what they bring. And you know, you don't always have to make it into a number talk that can take 10 or 15 minutes. It's just let them explore. And then we say, follow it straight away with another number that's slightly different. because that stops the kids falling into that safe category. Double and half is a lovely strategy. And often when you teach it for a week, all the numbers we use promote double and half. And then when the kid gets to something like this, they'll try double and half because it's worked all week. Why won't it work again? And then they get a bit hesitant. If they're older, they start to get annoyed, anxious, and then it's the old arms across the table. Oh, I can't do maths. I hate maths. So we always need to give them examples and non-examples of how things work here and give them that resilience and give them, that's what the growth mindset is about, giving them opportunities and questions to build the growth mindset. You don't get that through procedural stuff. So another one was like this one, looking at numbers. And this was great. I only did this week up in Whangarei before lockdown. I got stuck up there nearly for a day, but I managed to get back on Wednesday afternoon. And it's just great. The kids, again, just trying some things out here. I'm just showing the two teachers, look what the kids can do with these discuss and defend, talk, share. It's empowering you as a teacher to think, right, in 10 minutes, I now know the spread. I formatively diagnose where my class are. I can now use that for planning, because all these rapid routines are meant to be giving you some formative and diagnostic insights into what your kids can do. And at the same time, promote discourse and reasoning. And another school I said, Rob, we've taken you discuss and defend, and we've tried some of your ideas around creating a mini spiral of inquiry. And here, what was fascinating is giving kids across a different number of schools 2 different questions and then looking at the difference in ability with 1 week apart so the kids don't link. And again, as teachers thinking, wow, why is it that we've lost some of the kids in number 2? What can I do as a teacher to repair that? What can I do as a teacher to prevent that? What can I actually learn from some of these misconceptions? Well, let's have a look. We've got plenty of kids on number 2 going for 17 plus 32 is 49. And so they've got an error of not understanding that inverse operation. And I've got some kids here who just have a procedural error. So you've got procedural error and you've got conceptual error. 2 completely different errors that will not be remediated by the same approach. So these discuss and defend empowers us as teachers, as facilitators, very quickly to say, right, this group, I might just need a quick 5-minute reminder of how to subtract. That's you sorted. The group here, that's a conceptual understanding. I might need to do some explicit foundational work on the floor while my other kids are doing some open-ended for 20 minutes to give them power to understand it, and then I can put them back. That's not streaming, that's targeted intervention. And that's what all great teachers do. So it's making sure you've got time in your week to do these things as well. This is one school, and they've turned theirs into, a whole school approach now where the teachers have made some and they're starting to have a play. And I asked them yesterday if I can share their slide today. And they went, yeah, sure. We're teachers. We're happy to share, And so they're just trying to get some language around it now. And it's making the teachers just interact with things. But from a kid's point of view, there's plenty of opportunities to have your key need to know skills always spinning round, because it's regardless of what we're teaching at the moment, the teachers have identified the key ideas and we'll spin those round, because that's going to give our kids the maximum advantage. And number 2, move and prove. Move and prove, there's a few videos of these, and at the end I'll share you a site where I'm encouraging teachers to share some videos and photographs of these in action. They've been a bit reluctant at first, because as teachers we're like, oh, I don't really want to put mine up, mine can't be good, because we do tend to push ourselves down. But we're starting to make a few breakthroughs here. So at the end I will share with you a site that we're just having teachers who are playing with rapid routines starting to share, because as a teacher who teaches year 3, maybe I want to see what other schools do in year 3, because that's what we like to do as teachers, network. So move and prove again, what they're doing here, we're using a lot of those things. We're using the thinking out loud. We're using the talk moves. We're using that discourse all the time. And as a teacher, you can instantly assess your whole class. And the more the kids get into this once or twice a week, the better the kids get more relaxed and they start to realize. So schools who've been doing this are starting to see a change in that mindset they have. How they generally work is, and I'll show you how to make these in a moment, but the process involved can be 5 or 10 minutes. And teachers are choosing problems that they feel in their experience. Kids are making lots of mistakes. Sometimes they use old PAT type questions because multiple choice ones are actually quite good. Some teachers create their own. Some teachers get the kids to make them. Some teachers go onto sites like 3 truths and a lie and things like that and turn those into move and prove. You don't have to do the move and prove. I'll show you one way of adapting it. And then the kid, ākonga are told, we're just gonna have a quick move and prove here. And what's gonna happen is I'm gonna give you a question and I'm gonna give you 4 answers. 3 answers are tricks and 1 answer is the right answer. And when you see the question, I'm going to give you 20 seconds of quiet thinking time. And this is essential to have a think. And then I'm going to invite you to move. And the corners are your role as a teacher to get kids to value and associate mathematics is a time for explaining and proving, just like in science. Kids love doing the results and the experiment, but sometimes writing the conclusion, they can go, oh, that's so boring. But the conclusions, let's face it, are what having made virtually every invention we have today. There wouldn't be science without the conclusions. And you've got to say to kids, maths is about the reason more than the result, and some teachers have actually said, Rob, we've called your move and prove reason, not result. I said, go for it. I said, I like that. It's quite catchy. So reason and result to say to kids. So if you go to a corner, you've got to be able to defend it and justify it. If you don't know how to do that yet, you go to the middle and that's where you can listen. And then once you send the kids to the corners, you as a teacher can choose 1 or 2 kids to talk about it, and you get some amazing insights. I was going to show you some videos of this today, but I thought not really got the time, but I'll send you to the link where there's a few for you to watch, because I think as teachers, you want to watch them just to sort of see. And what happens is things like this, famous one from the late 90s by Carpenter and Fenwick, who looked at the lack of algebraic thinking. Now, this concept really is level 2, but it's quite capable of level 1, because kids already in other countries, by the end of 2 years of teaching, have mastered this concept, especially in Scandinavia and parts of Canada. And the kids are more than good to engage this. So this question was given against probably now about 2,500 kids in the last 18 months, 2 years. And what's fascinating is, as a teacher, just listen to what they say, because I've not been in a classroom yet, whether it's years 1 or 2, or whether it's year 9 or 10, where everyone agrees. And what happens is you get some kids saying it's 16 because, and they even say, Rob, you've got the box in the wrong place. What are you doing to us? You must be mad. So that tells me all I need to know there. You've got some kids not be able to get past that add 5. And that's often quite a majority. You've got some in the middle who are not too sure. They're a bit confused and they want to listen around. You've got some who are able to speak, and some who can explain. And the idea is, you're not meant to, in these move and proves, you say to staff, you're not meant to address this right now. This could be 2 or 3 years in the making. It's just for you to think, right, next week I need to do an activity where I can sit with some kids on the floor. It's basically giving you some planning insights, but it's giving kids that fun opportunity of walking around. I'll just share with you here, that's a lot of the data we've got so far. So I'll let you have a dwell on that at some stage. Another move and prove, this again, conceptual, visual. By the end of year 2, now we should be able to, as kids, know that 25 with bundling sticks is 1, 10 and 15 ones. Kids can cope with that, they do it. And that's real part of the nesting and this decomposition. And so it's in the curriculum as well, but like it's very hard to find it sometimes. So here we try this with a number of schools, and the discussions have been amazing. Why kids go to the bottom right. And they say, no, because you've got 3 here, that's your 10s, and you've got 4, that's your 1s. And some will go to the bottom, sorry, the bottom right and see those little 5s as 10s. But again, you get some, and the kids start to argue, the kids start to defend. And what some teachers said, Rob, is after that move and prove, what we did, I said to the kids, right, here's some MMB, go and make one yourself. Choose a number, and I want you to make an example of it and a non-example of it, which is a backbone of its basic instruction, because it's all about checking understanding and conceptual understanding. And then the kids, if they can make an example and a non-example, we know straight away they've got that conceptual understanding. They're unlikely to forget it down the track, which will save me a lot of time having to reteach kids all the time. Sit down with them, talk with them. They were there, and it was great to see a move and prove being adapted, and basically it was turned into a mathematical inquiry. The beauty of this inquiry was it wasn't just another story shell transparent word problem that sadly make up too many inquiry problems. Inquiry problems themselves are meant to be group worthy, and they're meant to be more than 2-step and bring things in. So another session down the track that I put a video link to is working with teachers last week about how you can categorize the right sort of problem if you really want to maximize multiple ability ease with your kids. So that's something that we can look at. Another move and prove that's got teachers writing into me with their results, which I love. And that's another thing this network does. Teachers like to know, it's not just me, is it, Rob, that I did this with year 7 and 8 and half my kids got it wrong? I said, no, it's not just you, it's everywhere. And this one here, we had some fascinating insights. And the kids were on there explaining. One school down in South Auckland I was with 2 weeks ago, we just put them out the window at the side, and it soon became interesting how kids started to gather around and start to look at them. And then we just went out and said, okay, what do you think? Oh, I don't know, I think they're all hexagons, aren't they? Or it's just inviting those insights into them. And what we found was so many kids, and I would love you to try this where you can't, even you can put these on Seesaw. Some schools said even in lockdown, these can go on Seesaw and you can ask kids A, B, C, D and collect some information off them. But we found by year 7 and 8, 2/3, up to 60% of 7 and 8s across 24 schools were unable to confidently say what the hexagon was. Now that's in level 2. So what we did, we went straight to year 2 at the bottom, and we got them to show us examples and non-examples of hexagons, and we smashed that misconception before it started by showing kids. So these move and proves, I said, the more you play with them, the more insights you get as teachers, and you'll start to share amazing things with the kids and things that will stop them getting these errors in thinking. A few schools have done some of these. They've made their own move and prove by getting kids to do it. And this was early, foundation. I was sent videos of foundation kids really getting stuck in with proving it, defending it. Brilliant, really, really good. So it was a foundation stroke year 1. And it was just great to see, that these kids that know, if we have got low floor, high expectations, let them have a go with this, because they really go for it. And even with year 8, 9 and 10, one school says, Rob, we've taken a slight tweak with your move and prove. We actually share kids' test examples and get kids to either say which one did they think the teacher thought was the best and why, and this one here, which one matches your thinking. I love it, because you've got this, 2A times 3B. And the one that I think most high school teachers found amazing was the one on the top right corner. The answer should be 5A times 3A equals 15B, because A times A equals B. Now, for me, I said to the teacher, there must have been an experience once where maybe the kid did that, and in our busyness, we ticked it right. But there's obviously something with that kid that they have got proof somewhere along the line that A times A equals B. I don't know where it is, but who knows? But it's fascinating as a teacher, Rob, to go and find these things out. So those are your move and prove. Third sort of recall and reason. There's hundreds of these out there, and they're just games. You know, games, especially for number, that you can use to formatively assess. My schools, one of the things I'm doing is to basically move away from having to do any gloss one-to-one interviews. They are totally unnecessary for a whole class and should only be used formatively for just one or two kids, because they don't actually match a lot of the elaborations. They have their place, but they can all be done formatively through games. So there shouldn't be any reason to do one-to-one interviews at all. But what we've got here is kids investigate 3 numbers. And sometimes I say to teachers, well, if they're younger kids, give them 4 or 5 numbers, in fact, to have a play with. And what you do, you use a bit of creativity. At the moment, this recall and reason one is a game that they play on their own. But when I first do it, we say to teachers, do it as a whole class, because already I'm probably got some of you who are problem solving. You're thinking, how did Rob get the number 91 using a 361? So obviously we've now got a problem, because the definition of problem solving, remember, is an authentic task that you don't know the answer to straight away, but you probably have the prerequisites of skills to put together to have a go at developing or formulating a strategy. And that's why it's good to show the kids, because we said to them, you know, you can be creative with maths. If things come up using a 3, 6 and a 1, have a play, because we found that even in level 1, some kids in year 2, because they could use place value, could suddenly shoot at the board. The 3 is 10s, the 6 is 10s, and the 1 is 1, 91, bang. And I, whoa, year 2, go for it. And you know, young kids are like meerkats, aren't they? They will look up and they go, what's over there? What's over there? Because the teacher wants to know, the teacher's gone over there and she thinks it's really good, or he thinks it's really good. As a kid in year 1 and 2, I want to emulate that, because I want that praise as well. And they're off. And it's just a lovely thing, because even in mathematical inquiry, the explore phase is meant to be when you're walking around, you can stop the class, bring them over, have a look, share. That's what it is. And sometimes I've been in mathematical problem solving where some teachers say, oh, Rob, we're not really allowed to do that. Well, you are. You know, you are allowed to do that, because that's what the original complex instruction and the research around that is. Use different ideas, stop the class, praise them, bring the kids over, let them look, share it. And at the end, I can share with you an article I shared with the teachers I'm working with last week on the original research of the launch explore, because there's a lot of mixed messages out there. And I think, again, teachers just wanted some clarity of where to go for this. So there's games. This one was done in years 1 and 2. Same thing, rapid recall, the games were played and the kids had to get 3 crosses in a row. And what was happening here was the kids had to, in groups of 2, defend it. So they're having to, you know, show their proof. So one cross was, well, 10, subtract the 2 is 8. Check if it's right. Yes, you can have that. Cross goes in. And they were playing a game with numbers. And then we took it outside. And this is what I love about the kids. So these are year 2s. We took it outside with the teachers and we got the kids to draw it, play it. And then we had a bit of an argy-bargy, because one kid was on a cross and they wanted to replace the cross with theirs. And they said, what happens if I've got 6 and the girls are already on the 6? And I said, well, what do you think might happen? And they had a bit of a chat. And one said, maybe, and these are year 2s, maybe we could, to knock someone off, we've got to make the same number using 3 numbers, 3 add-ends, not 2. And I said, what a good idea. I said, would that work every time? And they were like, yes, because if it does, then let's give it a go. And so it's just so great to go and share that with the other year 2 kids as well. Like, kids are playing, and it's a lovely, and again, said, I don't need to interview. I can sit there with the group and see if they count on, count all, if they're early additive. I can see that right in front of me in a fun way, not, and it gives you as a teacher that power to know exactly where your kids is all the time as well, rather than having to wait, you know, maybe for an interview in week 8 or 9. And it doesn't take you away from teaching time. because to becoming a way to teach or interview kids takes us away from actually teaching them stuff. So all these games can replace nearly everything on most of those interview tests, and it's a bit more fun. One from Peter Sullivan, that one that he shared was a great one, and the kids just draw blocks, and in the middle you have your two parts. If you add them together, the sum goes at the top. If you multiply them two together so they become factors, the product goes at the bottom. And by changing the missing number changes the level of cognition. So the middle one here, you see, sorry, the top right has a bit more cognitive effect because the kids have to think, oh, what two numbers add to make that? So it's problem solving. Because don't forget, problems don't always have to be words, visual and infographic type problems are really important. So don't get hung up on thinking all our problems have to be nice little word ones. Mix them around a bit so they're there. And then this one, rapidly done. This one we made last week, just if I know, then I know. And we're trying it out with the kids to say, you got more accountability. I will give you one fact, or you choose your own fact. And with a group for 5 or 10 minutes, I'd like you to investigate this. And at first, yes, it's like getting blood from stone. I can tell you now, because we go grade 4, 5, and 6. When we first had a play with a similar one back in Queensland, even in the big decile 9, 10 schools around Noosa and those places, the kids are like, what again? But after a few weeks of perseverance and a growth mindset by the teachers, kids started to get the hang of this. They said, right, this is your homework for the term. They even said to all the whānau and the parents and caregivers, would you be able to use this, whether you're year 1 or year 8? This is your homework for the term. Sit with your kids and get to explore, because this is a bit like the flip classroom. If you can do this, your kids can show you, because we're going to show them how to do it in school. Sit with your kids, get them to talk, get them to link, because kids are told, if you know your times tables, it'll help you. Well, they do if they can use the inverse, if they can link it to place value, if they can use it to find fractions and things. Times tables don't help them if no one's shown them how they interact. And that's what we need to be able to do, make sure that they can link and do those things in it. And the last one, taking the time, looking good, is just a few open up ideas. And I've just put these in here just for you to have a look at. I'm sure you've got your own. Peter Sullivan's got a load of stuff on open-ended, and there's plenty of things out there as well on different sites. And this one in particular was one we did in our small schools. So schools that had less than 50 kids, to show teachers that, look, we want some tasks here that we can do with a year 1 4 composite class, a year 3 8 composite class, because some schools have that. The smallest school I had under my jurisdiction in Queensland, I had about 50 schools with less than 50 kids in it as part of the 250 in my area. But the smallest school was 3, and yeah, that was interesting. But they said they never had PD, but we just actually based ourselves there, and the other schools within an hour's radius all came to that school. So the school just like bulged by about 1,000% in terms of size that particular day, because they bussed kids in for a day as well from about 4 schools, which is great. And we just got together and just did, and we tried things out. If they work in these sorts of schools, they can easily be adapted. So here we got the kids to say, look, show us your equivalence, show us your number fact skills, get ready to justify, get ready to defend, use similar operations on both sides, or go to red, use opposite ones. And then the teacher said, 2 at the back, I'd like you to do that, but obviously you're level 4, so we'd like you to show us how much you understand about fractions, mixed numbers, improper fractions. And again, suddenly you can take that into the year 1 and have kids making these with manipulatives and models, and walk into year 9 and do it with improper fractions, and decimals, and they're all having a go. And I think when you start to make these and build a repertoire of these, it just helps the teacher. This could be used once a week every 4 weeks. and use it to assess so much stuff. So they're just really useful things. Here's one, see, and the kids just having a go. I said to the teacher, if your aim of this was to diagnose what the kids can do, just have a look. You know, it takes 5 or 10 minutes. If you want to choose them up, put one up on the board and get kids to talk about it. If you see some errors, can the kids identify which of these scales is wrong, why it's wrong, and what do we have to do to make it right again? And other ones, I won't bore you with too many of these, but you know, they're just ideas. And I'll put a couple of links in an email to everybody as well about those. And differences, let the kids choose. You can choose a difference of 7, a difference of 10, a difference of 15. You can choose a difference of 1.5. You can choose a difference of 3/4. So suddenly you can see, whoa, there's so many different ways of doing this. And if you have that elaboration document in front of you, you can sit with the group and look exactly how to, you know, cater to the diverse range of kids pretty fast as well. I'll just do a couple more. That's a fraction one. And even a shape one, you know, that's 3 truths and a lie. Can you do your own hexagons? Can you recall the reason, the perimeter, recall and reason the area? And I've put these in just to show you some ideas that, you know, we're making with teachers. Because I said, give teachers trust and time, and you've got yourself some amazing resources. Last one, snapshots. This is just an interesting one. And if you want to know more about this, you know, feel free to contact me, because I'm happy to share, because it takes a bit more detail these. But we wanted to know what drives kids. So we basically explained to kids over time, you know, when you see a question, you want to know what happens in your head. So we explain these really carefully to the kids. And what we did is we basically put a question up on the board after the kids were explained, and we gave them pieces of paper, and they were very honest about what they said. You can see here, I did about 1,000 of these. Collecting the data, I offered to take the data, analyze it, to look at the dispositional things. And what was fascinating, if I take you back to this one we did with year 3s and 4s. We showed the kids a question like that. One said, had this explained. And this is the sort of responses. The top one are the kids who just refuse. You know, the blue, dark blue, are the kids who have linguistic barriers. The orange are the ones who hesitate and get anxious when they're actually problem solving because they don't know which strategy to use. The green are your kids who are right and end up being right, but they're not necessarily always effective. And the red are the kids who think they're right and they're wrong. And as teachers, those are the kids that probably give you the hardest headaches, I suppose, because they think that, and often their mums and dads think they're, you know, a genius as well, and that doesn't help us. So those ones are always interesting, because if the red ones don't get the intervention, and that's your breakdown, that's 1,074 year 3 and 4 kids. But if you do this, it just gives teachers, you can't, you know, again, just a really interesting snapshot, not just about their performance, but about their disposition, their well-being, their self-efficacy, their self-agency. And again, it's like, what can I do to bring those few top ones over? Because if I've told them they're doing additional week and I know they hate it, they're going to be outside in the yard thinking, oh God, it's maths next, how boring. And if those are now year 8s or 9s, that behavior manifests itself as disengagement, disruption. And these are a fascinating thing to do. We've done them up to year 13. And yeah, I'll be right. Some of the year 13s have given me a bit of choice language to wade through, but at least they were honest, as they said. Summing up, where can they go? Well, if you're planning in 2-week blocks, like a lot of the new updated units from NZ Maths do those 2-week blocks, and they have a really good sequence of things that are worth having a look at if you've not been for a while, then we're not going to say change your the way you plan. But what we do is, when you're choosing any rapid routine, we make sure in a term you've kept things alive. Because if, for example, shape's coming up in term 3 and you've not done shape for 8 months, 9 months, that's not telling the kid it's valuable. Often our planning is teacher focused, it's not student focused. That's no one's fault. It's textbooks are the worst. They just put things down, fill it up, and just sell themselves. And what we can do is scatter them and watch the difference in retention. because it really does help. I've got a few articles, but and a research paper on this. But as teachers, you don't want to read all that stuff. Just show me what they look like is what we want as staff. And again, where can they go? In a typical week, just pepper the rapid routines. I do this with teachers who want to know how when they say to me, Rob, over the years, how do you balance group work, individual work, inquiry, explicit? And I said, there's not one answer. No one will tell you there's one answer. It varies on a teacher. If you're new to inquiry, if you're not very confident with maths, just try an inquiry once a week and use the same question. You don't keep having to find new questions all the time, and break it up until you feel confident to move forward. No one should expect to watch you teach unless they model first. No one should really expect you to do a whole focus approach on one way or other. That's wrong. And it's not fair on us as professionals. We need to make sure that we are treated as professionals if professional learning comes our way. And it needs to satisfy our needs and our wants as well. That's important. So, quick one. I can send a few of these things. They're not finished yet. So I'll be honest. I send things out to my schools, have them for years, unfinished, not because I'm lazy. It's because sometimes I say, look, I want your ownership. There's no point in making something and giving it to you. What do you think? Change it. So this one here, I've had schools from Invercargill, Dunedin, Whangarei say, Rob, how about this? Tweak it this. Could you make it look like this? Bring it on. Happy to help, happy to make things that work for you guys. And it also comes with a tracker. That's what schools are using just to check, are we covering all the things in a typical term for the rapid routines? And the site, the Facebook site, it's a private group because obviously it shares photos and things, but a lot of people just come on just to take ideas away. And then the project I'm doing with the ministry at the moment, because I'm doing basically taking all the research and resources in New Zealand, I've been asked to just run a pilot project with a number of schools across 4 regions. And I'm just helping the teachers get to grips with what does a succinct look at rich inquiry look like? What does a succinct look at formative assessment look like? And I've just said, even though they're meant to be for the project, let's just open these up. There's a few examples there that when you get a copy of this, you can click on those things and just feel free to download, have a play. They're all free, all available.